Trigonometric ratios are usually used in situations whereby we have right-angled triangles. Now, you know that in a right-angled triangle, there is one famous side that we always call hypotenuse. That side does not change, it's always the hypotenuse, even in the instance when we are using or we are dealing with trigonometric ratios. The other two sides are named opposite side and adjacent side, depending on the angle from which you are looking at it. Now, starting with the introduction of the three trigonometric ratios, we know that three are sine theta is equal to opposite side of a hypotenuse, cosine theta is equal to adjacent side of a hypotenuse, and tangent theta is equal to opposite side of a adjacent side. These three give the famous acronym SOHCAHTOA, meaning sine is equal to opposite of hypotenuse, cosine is equal to adjacent of hypotenuse, and tangent is equal to opposite of adjacent. Now we have some examples here we are supposed to tackle. The first one here is a situation whereby we are supposed to get the length BC. BC is this one here. You can see we have been given 53 degrees and 27 centimeters here. Now what you need to do is to identify the line you are given and these other sides, at least one more of the sides remaining. Of course, we have been given this side. This one is always the hypotenuse. So considering this angle here, you realize that if you place your eye here, the line you will directly be looking at will be line BC. That will be the line that is opposite to your eye, and therefore we call this side the opposite side. This is the opposite side. This is the side which you directly look at if you position your eye in the angle that you are given or the angle you will use in calculation. So if this one is opposite and this one obviously is the hypotenuse, then definitely this one is the adjacent. Now, as I've said, this is the opposite, and then we have hypotenuse, which you have been given as 27 centimeters. Now, these 2 quantities are enough for you to get this side, remaining side. So you ask yourself, which trigonometric ratio uses hypotenuse and opposite? So you realize that tangent uses opposite and adjacent. We don't have adjacent side. Cosine uses adjacent and hypotenuse. We don't have the adjacent side. Sine uses opposite and hypotenuse. We have opposite and hypotenuse. So we shall use sine ratio. We shall say sine theta is equal to opposite side over hypotenuse side. So that means sine, the angle you write here is the angle you have considered in naming these sides. We have considered angle 53. So we shall say sine 53 degrees is equal to, which is the opposite side. The opposite side is the one we are looking for, BC. So we write it BC the way it is over the hypotenuse, which you are given as 27 centimeters. Now we can get sine 53 from the tables. So we go to the tables and get sine 53. Sine 53 here is an extract of natural science. So sine 53 is here. You look for it in the 0 column. So we shall have it as 0.7986. 0.7986. 0.7986. Here it is. That's equal to BC over 27. We are looking for BC, so we multiply both sides by 27, and that will give us BC being equal to 27 times 0.7986, and that is 21.56 centimeters. So that means line BC is 21.56 centimeters. Another example is this one, where we are supposed to use to find PR. PR is this one. Then we have been given 15.5 centimeters for PQ, and we have this 24.23 degrees. So let's consider the angle that we have. So considering this angle, the line we are looking for, which is PR, if you place your eye here, the line you will be looking directly, or the line that will be direct opposite to you, is this one, PQ. So this is the opposite side. Then remember, hypotenuse never changes. It's always the hypotenuse. It is the longest side. So we have hypotenuse, and this is the opposite. So definitely this is the adjacent. So that's why we shall say PR is the adjacent side. And the one we are given, its measurement is the opposite one. Of course, I've shown you that if you place your eye here, you will directly be looking at this line, and therefore it is the opposite side. Now, which trigonometric ratio uses opposite and adjacent? Sine uses opposite and hypotenuse. We don't have hypotenuse. Cosine uses adjacent and hypotenuse. We don't have hypotenuse. Tangent uses opposite and adjacent. So we shall use tangent. Therefore, we shall say tangent theta is equal to opposite side over adjacent side. So the tangent of the angle we have considered, is 24.23. Is equal to opposite side. We have realized it is PQ, which we have as 15.5 centimeters. So we write 15.5 centimeters here over PR. PR is the one we are looking for. So if we multiply, if we get the tangent of 24.23, we shall get it being tangent 24.23, 24.23. Here is an extract. So we are looking for tangent 24.23. 24 is here. And then this column 0, 1, 2. So column 2 is this one. The number is 0.4494. And then column 3 here, this column 1, 2, 3. So it means we take 6 here. And remember, we are adding. So that means we shall take 0.4494 plus 0.0006. So we shall go back. We get that one. We have 0.4494 plus 0.0006, and that gives us 0.4500. So that is the value of tangent 24.23. So we shall replace this one with this value. So 0.4500 is equal to 15.15 over PR. We want to get PR, so multiply both sides by PR. And of course, this and this cancels, you remain with 15.15 here. So we shall have PR times this, giving us 0.4500 PR, being equal to 15.15. Divide both sides by 0.4500 to get PR. So if you do that, you will get your PR being equal to 33.67 centimeters. The third question wants us to get, let's see what it's looking for. Or we are looking for theta. We are looking for theta in this case. So we consider the angle we are looking for and say, considering this angle theta, one of the sides we are given is XY, this one here, and this one is always the hypotenuse because it is the longest side, and it is 60.3 centimeters. The other side we are given is this one, YZ. What is its relationship with this angle? Remember, if you place your eye here, the line you will be looking at directly opposite to you is this one. So this is the opposite side, XZ, meaning this is adjacent. So that's how we have concluded this way. And its length is 56.35. Now the question is, which trigonometric ratio uses hypotenuse and adjacent? You will realize that this one uses opposite and hypotenuse. We are not interested in opposite. This one uses adjacent hypotenuse, so we take cosine. Therefore, we shall say cosine of the angle we are looking for is given by adjacent side over hypotenuse side. The adjacent is 56.35 over the hypotenuse is 60.3, which if you divide, you will get 0.93449. But remember, we are dealing with 4-figure mathematical tables, and therefore we cannot be able to read this. We shall round this correct to 4 significant figures as 0.9345. So we are looking for the angle whose cosine is 0.9345. In other words, the cos inverse of 0.9345. So we shall go to our table. We are looking for 0.9345. Look for 0.9345 inside here. We cannot get it readily because this is 0.9348 and this is 0.9342. The number is supposed to be between these two. Now, which one we take of these two depends on what this section is requiring us to do. We are supposed to subtract whatever we have in this side. So it means we shall take the higher value, which is 9348, and we subtract something there from there so that we get 0.9345. And that something is 3. So that means now we read the angle which has these figures here. So to the left we have 20, and above we have 8. So that's 20.8. And then the one to which this 3 corresponds to is 5. So the value of that angle is 20.85. 20.85. So we shall have the angle being 20.85. So that's how we work those questions. Now, one thing you need to note is that the adjacent side and opposite side are never stationary. They change depending on the angle you're looking from. If we consider this angle, we realize this is an adjacent side. But remember, if we could have used this angle, if we could have considered this angle, this side could be opposite and this one could be its adjacent. So it is not cast on stone that this side is always the adjacent. No, it depends on the angle you are looking at it from. Thank you.